Hello everyone. Welcome back to Python Challenge for All. Okay, let's see where we were last time.
So we tried to draw a more accurate circle and trying various ways of writing polygons and then polygon circles to have better overlapping. Okay, I guess for some people it was difficult to understand because it uses advanced mathematics. Um, Sorry about that, but I hope someday you will understand that. There was no homework, so just go on. Let's before that, let's quickly check that. So it was like this, and so just save the file, and maybe we will go on to a new notebook. So open, and no, not open. So from here, new notebook. So let's go on to E4. Okay, so new notebook, connect it, close the last one, and name it as E4. Okay, that's fine. Okay, so where are we? Okay, treasure hunting game, good. So we'll be making several variations of very simple treasure hunting. First, today, it's only single line version, one-dimensional version. I hope you know what one-dimensional means. So you only live in you play on a single line. And so it's like this. Okay. The treasure is at some unknown position. So it's like we are on a single line. Start the leftmost position is 1, 2, 3, up to 9 on the right hand side. And treasure is at some unknown position, hidden. I don't know exactly where it is. Maybe we will make it using random function. And then you start from position 5, and you have, okay, what you only know is that the distance to the treasure from your position. So it's like, yeah, we'll do that using abs function. And then you have a choice of going to east, that is to right, or west, that is to the left. Okay, so let's play it. Let's make a game like this. So maybe we will be using random functions. So we need to import random. So as for treasure position, the treasure position is like we need to, okay, treasure pos equals tpos is like we need to initialize as land int. So something between 1 to 9, okay? Somewhere between 1 to 9. We don't know exactly where it is. And your position is, okay, 5, as I said. Okay, so then you start from position 5. Here only the distance to R. So this distance is calculated as the absolute value of tpos minus ypos, meaning that whichever is larger, the absolute distance between the two is given. Okay, so given that you can make a move of west or east, so it's input. Okay, input, you remember that? Input So you show the dist. Okay, let's make f variable. Dist is dist. Okay, and then east or west. I think this is good. Okay. So let's first just print what you give. Okay, so if you run it, okay, this is, yeah, so you have an option of E or W. Okay, so what should we do? When you say east, what are you supposed to do? Yeah, right. You need to move to the right. So you need to increment if imp lower. Yeah, you need to change it to lowercase. Okay. Equals maybe E. Okay. What you can do is increase pos. Your position, increase it by 1. Maybe else. Y pos minus equal 1. And we repeat this. So maybe here we need another if. When you hit the treasure, it's kind of you were done. You're successfully found the treasure. So if this equals 0, okay, you need to write done. And then you break the, okay, yeah, maybe this will be, and instead, okay, just and repeat this. Okay, maybe I think this is fine. This is for E or W, maybe west. Okay, there is no response. So maybe we need to make infinite loop. Maybe we will write instead a very long big loop and select this and tab once so that we can indent 4 spaces. And then, yeah, if distance is 0, break. Okay. Let's see if this is good. Before going on, maybe we can cheat so that our algorithm works fine. So maybe we will print the treasure position secretly, and also we will write down the my position, your position each time, so that it's working fine. Okay, are you comfortable with this? Let's run it. Okay, actually the treasure is at 2, yeah, here, and you are here, but you don't know which way to go. So let's go, well, west in the beginning. Okay, then your position is now 4, which seems correct. Okay, distance is 1 smaller. Okay, that's fine. Okay, let's see what happens if I put E here. Then if I go to east, to the east, to the right, it means I'm away from the treasure. So distance should be bigger. It's wrong. What's wrong? E, if I give E, then bypass should be 5. Why is it at 3? We need to find out. So what's wrong with this? Okay, if the E okay, maybe this is too hard, so let's stop it. And let's find out what's wrong. The first letter, we need to check the first letter, and also we need to make sure that maybe if something else is given, maybe so that we can change it here. Okay, imp will be immediately changed to lowercase and input this. So we need to do it. E, and then E equals west. Okay. Let's print E here so that we can make sure what is selected. Okay. In this case, we will print W. Else, print, do it again. Okay, let's run this. Okay, let's go to east. Do it again. What's wrong? W. Let's check. I see. Okay, we need this one. To east. Good. East. Incremented, and the distance is larger. Fine. So W. Okay, this is good. W. W. Now we are approaching. Distance is now 1. If I go W. Okay, done. Okay, so we don't need these actually cheatings. Okay. I think this is good. So let's see. The problem was that I forgot about the pair parentheses. Okay, let's do it again. Okay, which one? We shouldn't know the answer, so maybe comment this out and run it again. Okay, distance 3. Let's go west. Oh, yeah, east. Okay, distance is larger, so maybe we were wrong. Go west. Okay, west, west, west. Okay, distance is 0. Why does it stop? Distance is 0. Why? What's wrong with this? Sorry. I should have put this before imp. Okay. Because if distance is 0, we don't need to check, ask for input. Okay, so this is better. Okay. Very simple one, but I think this is essentially fine. Okay, too simple, right? Okay, fine. So maybe next time we will go on to a little more complex ones in two-dimensional one. But this is the basic algorithm to do the game. Okay, homework. When done, write treasure was at X. Okay, hope you'll come back next time. Bye-bye.